Hello students, this is Max Club CBSE. In this video, we are going to discuss the first chapter, Relations and Functions in exercise 1.1, sum number 12. Okay. The sum is, show that the relation R defined in the set A of all triangles as R is equal to set of all T1, T2 such that T1 is similar to T2 is equivalence relation. Okay, first part in the sum, the first part is T1 and T2. This is the relation defined in the relation T1, T2, that pair. How the relation is defined is T1 is similar to T2. Similarity between two triangles means their ratio of their sides are equal. Then only we can say that two triangles are similar. This is the known concept. Okay. This relation R is, we have to prove that this relation R is equivalence relation. Okay. In the first part, we have to prove this relation R is equivalence relation. Equivalence relation means we have to prove that R is symmetric, reflexive and transitive. Then we can say that R is equivalence relation. Okay. In the second part, consider three right angle triangles T1, T2 and T3. These three are right angle triangles. T1 with sides 3, 4, 5. T2 with sides 5, 12, 13. T3 with sides 6, 8 and 10. The question is, among these three right angle triangles T1 and T3, T1, T2 and T3 are related. Okay. Which triangles among T1, T2 and T3 are related? This is the question in the second part. Okay. First we have to prove that R is an equivalence relation. Okay. Now we have to give the, here we are giving the solution. First we have to write the given relation. That means R is equal to, the given relation R is equal to set of all T1, T2. This is the pair in the relation T1, T2. How they are related? The relation definition defined in the sum is T1 is similar to T2. This is the relation. T1 is similar to T2. This is the given relation. Similar means T1 is similar to T2. That means ratio of their sides are equal. Then we can say that T1 is similar to T2. Okay. First, R, we have to prove that R is an equivalence relation. For that, we have to check reflexive property. Okay. Reflexive property. Reflexive property is, that means here every triangle is similar to itself. This is a known concept. Here, since every triangle is similar to itself. Every triangle is similar to itself. Okay, this is a known concept. Because every triangle is similar to itself, it's a known concept. Therefore, we can say that triangle T is similar to triangle T. Okay, triangle T is similar to the same triangle T. Okay, triangle T is similar to the same triangle T. Therefore, what is the meaning of this is, this statement is T, T belongs to R. That means here R is reflexive. Okay, R is reflexive. Here we proved the first property, R is reflexive. Okay, now another second property, check symmetric. Check symmetric. Okay, check symmetric. That means here we have to prove that T1 is similar to T2. Then we have, this is the assumed condition. T1 is similar to T2. This is the assumed condition. Then we have to prove that T2 is similar to T1. That is the symmetric property. So here, if T1 is similar to T2. Okay, T1 is similar to T2. This is the assumed condition here. Then we can easily say that T2 is similar to T1. This is the, automatically we can say that if we change the place of T1 and T2 here, again T1 is similar to T2. That means if we change the place of T1 and T2, here T2 is similar to T1. This is the, automatically we can easily we can say that T2 is similar to T1. This is the concept here. So we can write, so if T1 comma T2 belongs to R, that means T1 is similar to T2. Then we can say that T2 comma T1 we proved here T2 comma T1 belongs to R. That means T2 is similar to T1. The relation condition from the given relation is satisfied by this these two statements. Okay, hence the symmetric condition is proved here. Hence R is symmetric. Okay, R is symmetric. Now the third one is check transitive. We have to check the property of transitive. Okay, transitive means we assume two conditions here. T1 is similar to T2 and T2 is similar to T3. Then we have to prove that T1 is similar to T3. This the third condition also automatically we can prove here. Okay, if T1 is similar to T2. Okay. Now another assumed condition is T2 is similar to T3. T2 is similar to T3. These two conditions are assumed here. T1 is similar to T2. This T2 is similar to T3. That means automatically we can say that this T1 is similar to T3. Okay. Therefore, here then we can say that T1 is similar to T3. Here we proved the third condition. That means this relation is transitive. Okay, we can say that, so if T1 comma T2 belongs to R, T2 comma T3 belongs to R, then we can say that T1 comma T3 belongs to R. Okay, so we can say that R is transitive. The third property satisfied by the relation. Here we proved R is reflexive, transitive and symmetric. Okay, so R is reflexive, symmetric intransitive. These three conditions are satisfied by the relation, given relation R. So, R is equivalence relation. Okay, R is an equivalence relation. Okay, now the second part, R is an equivalence relation. Now, here we have the second part in the sum. Consider three right angle triangles T1, T2, T3 with respectively sides with respectively these three sides. Okay. Then the question is, which triangles among T1, T2 and T3 are related? Okay. Now the solution for the second part is, given relation R is equal to defined like this, T1, T2 such that T1 is similar to T2. This is the given relation here. Now T1 is the right angle triangle has sides 3, 4, 5. 3, 4 and 5. Another right angle triangle T2 has sides 5, 12 and 13. Okay. Another triangle T3, right angle triangle T3 has sides 6, 8 and 10. Okay. These three triangles are right angle triangles with the sides. Okay. Similarity. Here we have the definition of similarity. Similarity means two triangles are similar. That means if ratio of their sides are equal. This is the similarity definition. Two triangles are similar. Here I will write the definition of similarity. Two triangles. This is for understanding only. I will write here. Two triangles are similar. Means if ratio of their sides, okay, ratio of their sides are equal, then only we can say that these two triangles are similar. This is the definition of similar triangles. Okay. Here we are taking three triangles T1, T2, T3. Their sides. Okay. If we take T1 and T2, then their ratio of their sides are not equal. Here 3 by 5. 4 by 12, 5 by 13. They are not equal. If we take T2 and T3, their ratio of their sides are also not equal, because 5 by 6 not equal to 12 by 8 not equal to 13 by 10. Okay. If we are taking T1 and T3, their ratio of their sides are equal, because 3 by 6 equal to 4 by 8 equal to 5 by 10 equal to 1 by 2. Their ratio of their sides are equal if we are taking these triangles T1 and T3. Then only here these, when we are considering two triangles T1 and T3, their ratio of their sides are equal. Okay. Now here ratio for triangle, consider, here we consider two triangles T1 and T3. Okay. So for triangle T1, T3, ratio of their sides is here considering T1 and T3. Okay. T1 has sides 3, 4, 5. Okay. T3 has sides 6, 8, 10. Okay. Ratio of their sides is 3 by 6 equal to 4 by 8 equal to 5 by 10 equal to 1 by 2. Okay. Their ratio of their sides are equal here. Since ratio of sides is equal. Okay, this is the definition of similar triangles. The ratio of their sides is equal, then T1 and T3 are similar from the definition here. Okay, we can say that T1 and T3 are similar. T1 and T3 are similar means they are related because the given relation is defined R is equal to set of all T1 comma T2 such that T1 is similar to T2. This is the given relation in the sum. Here T1 and T3 are similar, that means T1 and T3 are related. Okay, the solution is T1 and T3 are related. Okay, T1 and T3 are related. Okay, up to this the 12th sum is over here. Please subscribe my channel Max Club CBSE. Like and share with your families and friends. Thank you.